Assalamualaikum. I'm Diva AAA from class Terbalik. So I would like to continue my lecture. Okay, we just stopped at chapter 1A. So now we come to the second part of chapter 1, which is electrochemical reaction at electrode surface. So the learning outcome for this part, so you should be able, at the end of this topic, you should be able to describe the mechanism of the electrochemical reaction occurring at electrode surface, and also you should be able to explain the factors that influence the electrochemical reaction at electrode surface. Okay, first you look at this slide. It shows the electrode reaction at anode as well as electroration or electrochemical reaction at cathode surface. Okay, so at the top you can see a diagram so showing this electrolytic cell. So for this topic we just focus on electrolytic cell, which is non-spontaneous reaction. So when it is a non-spontaneous cell or reaction, so you must have the top one. This is a power supply. You can use battery, okay, in order to make the chemical reaction in the beaker or in the solution to occur. Okay, so in this case, electrolytic cell, the anode is the positively charged terminal. For cathode is negatively charged terminal. So a lot of negative or electron appear at the surface of cathode, and the anode is the positive charge conquer or dominate the surface of anode. So anode is the positive, so the anion in the solution, anion is in the negatively charged species or substance, will approach the positively charged or anode, okay, electron. But for cation, positively charged ion, okay, will move towards the negatively charged surface of cathode. So the attraction will occur, so the oxidation will occur at the anode and the reduction will occur at cathode. So these are some example of common electro-oxidation. We call it oxidation because it oxidize to higher state substance or species. At the same time, it releases electron. For example, chloride from -1 will increase to 0 chlorine. At the same time, it releases 2 electrons. Okay, for the electrochemical reaction or electro reduction process occur at cathode, is the opposite reaction will occur where the electron will be accepted, will be consumed by the substance. For example, water, ferrum 3 plus will use or will consume 1 electron coming from the cathode surface, so it will reduce. For example, ferrum 3 will reduce to ferrum 2, 3 decrease to oxidation state. So also the alkaline, the formation of alkene from the unsaturated to saturated also can be done using electrolytic process. Okay, let's have a look at the mechanism of the electrochemical reaction occurs at the electrode surface. Okay, so this slide shows the mechanism involving the mass transfer as well as electron transfer. Okay, so this O, capital letter O, represent oxidized form or species in bulk. This is the oxidized species at the surface or adsorbed oxidized species at the electrode. The second step, the first step is the mass transfer mechanism. The second step, the electron transfer mechanism. So oxidized surface will receive electron from the surface, electrode surface, then it will undergo the electrochemical reaction. It will produce reduced species at the surface. Then the last step is involving the mass transport again, which the R reduced species at the surface, or the adsorbed species of R reduced species move away or diffuse away from the electrode into the bulk solution as reduced. Okay, this is the diagram showing that this is the bulk which the concentration of oxidized species is uniform in this area. It will move towards the electrode surface. So in this case, is oxidized, for example, ferrum 3. This is R, ferrum 2. Okay, ferrum 3 will reduce to form ferrum 2, involving all these three steps. Okay, mass transport, electron transfer, followed with mass transport. So the movement of the oxidized in bulk to the surface or adsorb is due to the mass transport mechanism, and it will reduce due to the different in concentration. This is higher concentration, at the surface lower, so it will migrate or diffuse from higher to lower and adsorb at the surface. At the surface, the second mechanism or step is the electron transfer step. So the electrons at the electrode will jump to the oxidized species already adsorbed at the surface. Then it will turn to reduce to R, reduced species, still adsorbed at the surface. Then it will move away to go into this bulk solution through or via a mass transport process. So it involves three steps. One is mass transport from the O from in the bulk to the surface adsorbed, followed with the electron transfer. It changed from O to R, still at the surface. Then the third one is it move away, and through mass transport it go to the higher concentration from lower reduced species to the higher to lower higher to lower concentration in bulk. So slowly it will replace the O in the bulk solution. Okay, we come to this slide. It also shows the same explanation as the previous slide. Okay, this is the yellow strip here is the electrode. Okay, so this is the oxidized species as reactants will approach the surface of this electrode, so will undergo, this is mass transport, this is the electron transfer. So when enough electron to jump to the oxidized species, it will reduce to R. R is the reduced species. So then we'll go to the bulk solution as product. So this is R bulk. So this is the mechanism involved in this process. Okay, the reactants O is the oxidized, move to the interface. Interface is, it means that at the surface between the electrode and the electrolyte. So the electron transfer will occur via quantum mechanical tunneling. Okay, the gap, okay, between the different in concentration of the interface is about 2 nanometer. Okay, it's very small, very thin layer distance between the electrode and the surface where the electron will jump. So next one is the reduced species will move away from the electrode through the mass transport process. Okay, now we look at the electron transfer, also known as charge transfer driven process, or we just focus solely on the electron transfer process or mechanism. So electron transfer is one of the fundamental roles in governing the chemical reaction or electrochemical reaction. So look at this on your left hand side diagram is showing the electrode. Okay, this is the energy present in the electrode. Okay, and the outside here, this is the level the presence of species. or the reactants oxidized species, okay, approach the surface of metals. So this EF represent the Fermi level. Okay, that means that the energy, the highest energy in the of electron sit in that electrode. So in this case, on the left hand side, okay, it is not possible to for the electron transfer to occur, because the electron Fermi level, the electron seat in the metal, is not sufficient to be transferred to the oxidized species, the orbital. The lowest unoccupied orbital belongs to the oxidized species, which is empty. Okay, this is the highest, but is unoccupied. This is a lower, but is already occupied by the electron. So this is HOMO, this is LUMO. So the LUMO is still empty, still vacant. So the electron from the electrode, for example, from cathode, can jump to into this orbital to change the species from one to another. But in this case, on the left hand side, is impossible to occur because the electron energy in that cathode, okay, in that metal, does not is not enough to be transferred or to transfer into that the lowest unoccupied orbital, the LUMO. So, but in this diagram on the right hand side, showing that the Fermi level is increased to higher level. Okay, this is the highest electron in that cathode. Okay, so increase. Why it can increase? Because you just apply higher voltage in order to make the reaction possible to occur. When it enough voltage supply to that electrolytic cell, so the electron sit at the top of the energy level in the electrode will be sufficient to be transferred into the unoccupied orbital of the species, the LUMO. So it is possible, so that this reaction will occur. So enough voltage or current supplied to the system, so the electron will will transfer to the orbital. So this is the reduction process where electron jump to the substance or to the species at the adsorbed species at the in the solution. Okay, it occurs at the interface between the electrode and the electrolyte. It's already adsorbed, so enough current or enough electron, the electron will jump to this to the species. This is the reaction process. For oxidation process, the opposite process occur. The electron, which the substance, the species in those solution, which in electron, the electron will donate or will transfer to the electrode. This is anode. Okay, for oxidation, the electrode is anode. So the electron jump from the electrode, in the substance, the species, the reduced form. Okay, so they will jump to the electrode surface. Okay. Okay, now we'll look at the simple electron transfer reaction. It just involves one electron transfer. For example, in this case, is ferrum 3 plus will accept, will consume, will gain one electron transfer. Okay, it involves one electron transfer to produce new product, which is ferrum 2 plus. Okay, what will happen actually is ferrum 3 in the bulk solution will move through mass transport reaction or mechanism and approach and finally absorb at the electrode surface. This electrode is cathode because the reduction process will occur. So ferrum 3 ion will absorb at the surface of the electrode cathode. So when enough energy of cathode, the electron will jump into the outer layer, the outer orbital of ferrum 3 plus. So the electron will go into that LUMO. So it will change ferrum 3 to ferrum 2. Ferrum 2 plus form initially it is still at the surface of the cathode, which we can put as ferrum 2 adsorb. Then finally ferrum 2 plus will move slowly through mass transport to go into the bulk solution. So this is a simple electron transferation involving one electron transfer. Okay, the second case is about metal deposition reaction. It just involves two steps only. One is the mass transport follows with electron transfer. So this is the example of this case, which copper 2 plus in bulk solution. Okay, will move towards the cathode surface. Okay, so the movement of copper 2 plus ion from the bulk to the surface is through mass transport reaction. So then it absorbs at the surface of cathode. So when enough current supplied by the system, so these two electron will jump to the outer layer or outer orbital of copper 2 plus to form a new product, which is copper 0. So this is reduction process. So this copper 0 as solid, it will not go into the solution, back to the solution, because it's already copper 0 solid. If it will form solid particle or layer or coating on the electrode surface. Okay, this is the third case, which is more complex. It involves the formation of intermediate. So probably also involve a multi-step electron transfer. So for example, in this case, this is an organic molecule. Probably I'm not sure about the naming this compound, probably nitrobenzene, iodo nitrobenzene. So we'll undergo an electrochemical reaction. There is one electron transfer. Then we'll produce product which is a radical or an ion, which is unstable product. So this unstable product will undergo a chemical reaction by eliminating the iodide to form nitrobenzene. It also can undergo electrochemical reaction. The electrochemical reaction involves the electron transfer. Chemical reaction does not involve electron transfer. So this involves a multi-step 5 times electron transfer, as well as the addition of hydrogen plus. So it forms a new product, iodoamine product. So this is nitrobenzene to form amine benzene. So this is a more complex reaction involved. So from reactants to form new product which is intermediate, which is unstable. So then the electron transfer will occur. Then it will produce new products. Okay, now is mass transport. Okay, so there are three fundamental modes of mass transport. One is diffusion. Second is convection. Third is migration. So this is how the ionic species can move towards the electrode surface through diffusion. So what are the driving force? What is the driving force make the diffusion process? Is the gradient in concentration. Okay, in bulk solution, the concentration of ionic species is higher than the concentration very close to the electrode surface. So when there is a constant or gradient or slope, the concentration slope, so the higher concentration of species will move towards the electrode surface through the gradient because of this gradient in concentration of ionic species. So it always occurs close to the electrode when current passes and chemical chain occurs. So it occurs for all dissolved species. The second type of mass transport is convection. It is due to the forced convection, either naturally or by occurring by forcing the system with, such as by heating or stirring. Okay, so the ionic species will go towards the electrode surface by convection. So if you stir the solution, so the convection will occur, so the ionic species to produce the reduced species or the oxidized species will move on the surface, will absorb on the surface of the electrode, and the electrochemical reaction will occur. Okay, so the rate of convection is greater, much greater than rate of diffusion. The third type of mass transport is migration. So what caused the migration effect is due to the gradient in potential between the electrode, anode and cathode. So anode is the positively charged electrode and cathode is the negatively charged. So there is in between there is electrical field effects. So ion will move due to the potential field between the two electrodes. So the migration is not specific to reactants and products. So in order to eliminate the effect of migration, so a supporting electrolyte will be added into the solutions. So in this study, we just focus more on diffusion mode. Okay, for mass transport, there are three types: diffusion, convection, and migration. But we just look at only one mode, which is diffusion. So this is a diagram showing the nurse diffusion layer. So on the left, this is the cathode. So you can see the difference in colors of between the blue and white. Okay, the sky blue represent the bulk solution, which the concentration of copper 2 plus ion is uniform. So the white one is become less, okay, very close to the surface of the cathode. So the concentration becomes zero. It approaches a zero concentration. On the right hand side, okay, you can see the electrode anode is copper, so it start to dissolve. That's why the blue color is darker than the solution, the copper 2 plus bulk solution. So this again, the dark blue color represent the nurse diffusion layer of anodic, the near to the anode surface. This white color is the diffusion layer close to the cathode surface. Okay, so this is the diffusion, the distance, the layer, diffusion layer, also known as the distance between the bulk solution to the surface of electrode. So we call this nurse diffusion layer. So the blue color represent the bulk solution, so it's uniform. So the concentration of copper 2 plus is the same throughout this bulk solution, but near to the electrode it become less, declining. Okay, it will reach zero when it approach the electrode surface. So there is a slope. So we call this a gradient, concentration gradient. So this effect we will relate with the diffusion mode, how the concentration, for example, copper 2 plus ion will diffuse to the surface and absorb to make the electrochemical reaction to produce, for example, copper 0, a coating. It will deposit copper 2 plus from bulk, will migrate to the side, surface due to diffusion mode, so that it absorbs on the cathode surface. Then when enough electron energy to jump from cathode to the copper 2 plus orbital, so it will happen and will reduce to copper 0 and form a new layer or new thin film, which is copper coating. Okay, just zoom in the area which close to the cathode surface. Okay, we just see the close up between the I would like to show you the distance, the nurse diffusion layer, distance between the bulk solution and the electrode surface. Okay, so the existence or the presence of the concentration gradient, that gradient we call it delta. The delta is the nurse diffusion layer. So that is how the copper 2 plus, for example, in the bulk solution will diffuse towards the electrode surface, and then we'll do the electroreduction process to form a new coating, a new products at the electrode surface. So this delta or diffusion layer is only in nanometer size. Okay, I think that's all for today. So I hope that you will understand the first objective. You have be able to describe the mechanism of the electrochemical reaction occurring at the electrode surface involving electron transfer and mass transport. So I hope that you understand the mechanism that involve two processes, which is electron transfer process as well as mass transport process. So for mass transport, it consists of three different modes. One is diffusion, convection, and migration. So I hope uh, uh, kau faham tak? SPM lepas tak? Okay, bye. See you tomorrow.